So welcome back to Introduction to Organic Chemistry. This is a very important topic, and today in this class I am going to teach on the resonance structures and formal charge and acid base chapter. So to complete understanding of organic chemistry, it is very important that to know the what is the common functional groups are present in organic chemistry. Students are uh, so thoroughly they are confusing that. So what are the organic functional groups are present? So these are the common functional group. Rx is nothing but, so you can see here, so very important. So is nothing but Rx is nothing but alkyl halide. So example, so 1 2 3 n propyl chloride, and so double bond position is there. So now it is sp2 hybridization alkene. So it is a example 1 butene. If it is a carbon, triple bond will be there. According to IUPAC, we can call it is alkyne. Example 1 butane. ROH alcohol. Example 1 butanol. ROR ether. So very important, two lone pair of electrons are there. Ether, and it's a diethyl ether example. And RSH thiol. So example 1 butane thiol. And RS double, so like thioether. So this is the thioether, the common name sulfide. Example diethyl sulfide or dimethyl sulfide. These sulfides are very important in ozonolysis reaction. So and aromatic compounds like, so 4n plus 2 pi electrons. So aromatic compounds are arenes. So example, for example methyl is there, it is called a methyl benzene. And it is RC. Next one, this and all, another class is that carbonyl compounds. So other carbonyl compounds, example RCOR is called ketone. Example methyl ethyl ketone or 2-butanone. RC double bond OH, it is aldehyde. Example 1 2 3 4 1 butanol. RC double bond OH, it is a carboxylic acid. RC double bond OX, it is acyl halides. Example acetyl chloride. Anhydrides, RC double bond O, C double bond OR, it is called anhydride. And ester, RC double bond O, OR, ester. Amide, very important, RC double bond O, NH2 is called amide, and RNH2, so amines. So these are the important organic functional groups. And today, and we will see that some important concept in organic chemistry. So now the question is that, for example, in exam they given like this. The question is that, so consider the following table. So provide the bond length of a variety of carbon and halogen bond, so measured in angstroms. So now let it be, it is a alkyl halide or alkenyl halide or alkyne halides. So now the halogen maybe is a fluoride or chloride or bromide and iodine. So this data clearly shows that the bond length, so the bond length, you can see that if it is a fluorine is there and 17.40, chlorine is there 1.79, if it is a bromine 1.97 angstroms and 2.16 angstroms. If it is alkene substituted halogens, then if it is a fluorine 1.34, if it is a bromine, chlorine 1.56, bromine 1.88, and iodine 2.10 angstroms. If it is a triple bond containing alkyl halides, so now you can see it is a X, maybe the fluorine 1.27, 1.63 and 1.79 and 2.2. So this experimental data, it clearly indicates that the fluorine, chlorine, bromine and iodine, the size of the atom is increases, so that the bond length also increases, and the bond length also, once the bond length is increases, bond strength also decreases. So that is a very important concept. So that means that bond length, so bond length is inversely proportional to the bond strength. So that clearly you can see that once the bond strength is decreases, the rate of reactivity also increases. So that is, and next question, very important topic, is that which of the following is expected to have highest boiling point. So already we know that the boiling point, the whichever the molecules showing the intermolecular hydrogen bond that are having high boiling point. For example, dimethyl ether, no hydrogen bond. Methyl alcohol, it is their hydrogen bond. And epoxide, so and acetaldehyde, so in acetaldehyde also it will be there, but so among these four, the option is that methyl alcohol is the correct answer. So the answer is methyl alcohol. And you can see this is the one of the important estradiol is the treatment of so breast cancer drug. So it is a so very important organic compound. It's, so what are the functional group containing this estradiol? You can see OH functional group, and aromatic phenyl ring, and cyclic ring, aliphatic cyclic ring, and double bonds is there. So you can see that, and alcohol is there. So these are the functional groups are present in estradiol. Then another drug that is called phenylamide A2 is antibiotic, antifungus agent. You can see this is a special boric ester drug. And another important is that, for example, the question is, can see here atendiol and enalapril are used in the treatment of heart diseases. So this is the atenodiol and enalapril are used in the treatment of heart diseases. Identify, so what are the functional groups present. For example, here they given two important heart disease treatment drugs. So what are the functional groups? In exam also sometimes they may ask you, so what are the functional groups are present. For example, you can see, so now this is called amide, so this is RCONH2 is called, so amide functional group. And you can see that OR, this is the ether linkage, ether. And you can see this is called alcohol linkage, correct, no? So alcohol, then it is amine linkage. So these are the functional groups are present. And another drug you can see here, enalpril. So you can see that this is the carboxylic acid, RCOOH, and it is the NC double bond O, it is a amide. And ester, you can see this is called RCOOR. So now this is called ester functional group, and now it is amine. And arene. So in this one, carboxylic acids, amides, amines, and esters, and arenes. So these are the functional groups are present. Then comes to the another one. For example, carbon atoms with, so very important in organic mechanism to understand what are the so what are the formal charges are present in a given molecules. For example, we know that carbon is a tetravalent. Now one bond is less, that's why here you can see one positive charge here, and here one positive charge, and one positive charge here. And so very important, so for example, this formal charge is very important to understand resonance structures. For example, here you can see ROH, so we can remove this one, so it will become RO minus plus H plus ion. So ethoxide anion and H plus anion, and so that if it is a taken one H plus ion, you can see this bond OH2 plus. Now formal charge is positive, so this is the like that easily it can breakable, and so that even ethyl ether also it is having one positive charge. And very important, for example, this is the ketone, it abstract the one proton and it will form like this, this is the charge. And even cyclic ethers also it will positive charge here. So if it is there, lone pair of electrons are there here. And if it is a ester and carboxylic acid or carboxylate, So these are the typical examples of how it will form a formal charge and organic functional groups. So very important is that you can see hydroxymethylene furfural also one of the important. So we will see that because this alcohol also lone pair of electrons will be there and aldehyde is there. So these are the functional groups present in these molecules. And important how to represent a resonance structures. So this is the a tail and head model, and for example you can see here it is the, for example 1 2 3 4 5. So here secondary carbocation, so this is the wrong representation, so that it may not, so it's a very difficult to break a sigma bond. So this is the wrong representation of the conjugation representation. For example you can see that, for example methoxide anion is there, the flow of electrons is like this bad arrow. And another one, for example hydroxyamine is there, so hydroxylamine, so in this one O minus also, this is also bad arrow. So this is also, for example peroxide will be there, HOO minus, and again, so because so these three and allow, so these three are avoid the octet rule. So that is the, so then how to represent, for example bad arrow, this is also, for example, so toward the sigma bond is also wrong representation. And you can see ethoxide CH3 and CH2 and CO, because already this carbon is satisfied for tetravalent surrounding this carbon, so this is also a bad representation. So very important, it follows that octet rule. So what is mean by octet rule? It should be a surrounding 8 electrons should be there. So once it will, the pi electron shifted like this, so that oxygen get the negative charge and carbon will get positive charge, so that this carbon atom does not have an octet. So this central carbon does not have octet, so that it gets the positive charge. So what is the resonance? You can see because of this carbon is a positive charge and the electrons are flowing toward this side, and because of this side. So remember that a carbocation, that means carbon bearing positive charge, only has 3 bonds, not 4 bonds. So we can see here, because of it is allylic secondary carbocation, and because of this one is the only 3 bonds are present, so that the fourth bond can shift like this. So this is called a resonance. And for example, so practice this skill. So curved arrow violates, sometimes it violates, don't forget count all the hydrogen atoms and a lone pair of electrons, so that so very important to memorize that how many bonds, how many its valency and all. So for example you can see here ethyl triammonium, for example this nitrogen, so nitrogen is a trivalent, but it is having 4 valent tetravalent, so that it carries positive charge. And similarly, for example conjugation will we should shift like this. So now oxygen will get a positive charge, and this carbon will get a positive charge, and this oxygen will get negative charge. And even oxygen, now oxygen having lone pair of electrons, so that it can shift like this. So oxygen will get positive charge and this carbon will get a negative charge, so like that. So now, so here there is no conjugation, there is no a conjugation in this one. So once it will, so for example here the lone pair of electrons are there, H plus ion can attack here, so there is a cleavage of this one, and so it will form a carbocation here. And like this, these are the very important examples you can see. For example oxygen ethers is there and it is bearing positive charge, so that how you can neutralize means you can see like this. So even carboxylic acids and there, and alcohols is there. So alcohols, it can very, it will form and positive charge here, and it will lose, so it will form a carbocation here. And you can see this is the resonance. For example lone pair of electrons are there, and so pi bond can shift, so oxygen will get negative charge and this carbon will get a positive charge. So this is the representation of the resonance structures. and formal charge. And you can see here very important formal charges in resonance structures. And you can see because oxygen containing lone pair of electrons and this pi bond is shifted, so that pi bond because of this carbon get the a negative charge and oxygen get the positive charge. So and another question is that, so for each of the structures below, draw the resonance structures. So how to so please note down this how to write the resonance structure, because here positive charge is there, so pi bond can shifted here. And even you can see that esters, oxygen having lone pair of electrons, so we can write like this resonance structure. So these are the very so this is alpha beta unsaturated carbonyl compound, so that this oxygen so shifted because oxygen is more electronegative, so that so this is the resonance structures of alpha beta unsaturated. Even so for example ammonia is amides, so nitrogen bearing negative charge and this shift like this, so that so these are the typical examples of different resonating structures. And another important so draw the appropriate resonance structures. For example, you can see here this oxygen is there, so oxygen is two lone pair of electrons, so that this is the resonance structures. And here this lone pair of electrons is there and this carbon, so that this here get negative charge. And because of this oxygen having like this, and this carbon will get negative charge. And so that even amine having lone pair of electron and this carbon will get the a negative charge. So because nitro group is very, because it is a tautomerism, you can see this alpha hydrogen can shifted here, and like this resonance structures are possible. And even if it is a non O minus and this like this, so like this very very important, so resonance structures and all. So yeah, so you can see this bond can shifted here and this. So because it is a trialkyl ammonium of mine elimination, also there is a possible, for example like this, if it is a heating, so it will form a trialkyl amine. So these are the conjugated you can see very nice example conjugated systems. So once this carbon having positive charge and this double bond can shifted here, so that alternative double bonds are more stable. You can see positive charge is a, so to stabilize this pi electron can shifted here. So these are the very delocalized structures are very important. And please note down these are the delocalized and localized. So very important to understand where the electrons are. For example, here you can see that now these two electrons are localized pi electrons, but here if it is a aniline is there, so now this is the delocalized electrons. So and also you can see now this is the pyridine quinoline based compound, so now this is the this is the localized lone pair of electrons. And whereas in ferrol now these electrons are delocalized electrons. And you can see this is the imidazole based, so now this is the localized pi electrons, non-bonding electron. So very important, so in to student has to be identified a different. For example, you can see this bond can shifted here and like this and like this, and these are the different functional group. For example, you can see, and you can see negative charge is here like this. So if it is a benzene ring, even if it is a acetone, because of like this also a tautomerism is possible. And if it is shifted like this, and this pi electron can shifted and here, so like this, these are the student has to practice different electronic resonance structures. And also here also they, so please note down these are the some very excellent resonative structures, and please practice. Thank you.